Good afternoon, students.
Good afternoon, sir.
How are you today?
I'm fine, thank you. And you?
I'm fine too, thank you. Okay, so before we start our lesson today, let's pray together. Pray begin. Pray finish. Thank you. Okay, let's check the attendance first. Who is absent today?
I think nobody, sir.
Okay, nobody. Who is on duty today?
Me.
Okay, Shallow?
Yes.
Okay, please help me clean this whiteboard.
Okay, sir. Yes, sir.
Thank you. Okay, students, as I said every day, you must be active and study hard today. I want you all to be happy and have a great spirit in this lesson. Understand?
Yes.
We are still in the linear programming material. Last week, we discussed about linear inequality into variables. For today, we will discuss about the objective function and find the optimum value. Hopefully, after this lesson is over, you can define the objective function clearly and can determine the optimum value correctly. So, are you ready for the class today?
Yes, sir.
Okay, if you are ready, please open your mathematics textbook at page 20. Okay, please prepare your writing book and writing tools. Okay, students, let's talk about the objective function. What is the definition of objective function? We can say that objective function in mathematical model can be stated in the form z equals to ax plus by. So, objective function in linear programming is the function z equals to ax plus by, which will determine the optimum value. Okay, we are into the optimum value now. So, what is the definition of optimum value? We can write optimum value is the maximum value or minimum value of the given function in a system of linear inequalities. Now, we talk about how to find the optimum values. We have two methods. The first is using corner points method. And the second, we use ruler method. For today, we will discuss about the first method, that is corner points method. So the question right now is how we find the optimum value with using corner points method. So there are 4 steps. First, we make a mathematical model that consists of all constraints and the objective function. After you make a mathematical model, you should make a graph of all constraints. After you make a graph, don't forget to determine the solution region. Okay, with the solution region, you should find the corner points in the solution region. Okay? After you find the corner points, you must substitute the corner points into the given function. Specify the value whether you want to find maximum value or minimum value. Okay? Understand?
Yes.
Okay, to understand better, I have this figure. This is the graph. Anyone wants?
Me.
Okay, Cielo. Can you show us what is the solution region?
The solution region is this, the DHP, the blue one.
Okay, so the solution region is in the blue shaded area. Okay, and where is the corner point?
I think the corner point is point A, B, and C.
Okay, so we get that the corner points is A, B, and C, corner points of the solution region. Understand?
Yes.
Okay, so let's go to the example. Okay, student, let's go into the example. Can you see it?
Yeah.
Okay, you remember the 4 step earlier?
Yeah.
Okay, the first step we should make a mathematical model. So we already have it here, but we will write it again. So the first step is done. The next step is we should make a graph. So we already have a graph here, so we didn't need to draw a graph again. And we determine the solution region. We have the shaded area in the figure is the solution region of the linear inequality system. The next is we should find the corner points. The corner points here we have O 0, 0. We have A, that is 0,5. We have B 4,3. We have C 5,0. So here is all the corner points in this solution region. Okay. The next is we should substitute these corner points and find. We have the question cause the maximum fxy value. So we should find the maximum value. To be easier, we made the table. As we can see in here, we have point D, right? It's in the middle of the solution region. This is not the corner point, but we will test it whether if D is a maximum value or not. Okay. So we can write D 2,2. Okay, after that, in here, we write the objective function f x, y equals to 50x plus 40y. We substitute the corner points into this and we write the result here. Okay, with me, 50 times 0 equals 0 plus 40 times 0, 0 equals to 0. 50 times 0, 0 plus 40 times 5, 200. So we get the result is 200. For B, 50 times 4, 200 plus 40 times 3, 120. 200 plus 120, 320. Right. We have point C, 50 times 5, 215 plus 40 times 0, 0. We have the result is 215. So all the corner points, we have the value. We will test for the point D. 50 times 2, 100. 40 times 2, 80. Right?
Yes.
100 plus 80 equals to 180. Okay. Okay, we find all the values right here. So, in your opinion, what is the maximum value?
I think the maximum value is 320.
Okay, so we have here 320 as the maximum value requested in the question, obtained at point D when x equals to 4 and y is equal to 3. Okay, this is the first example. Okay, students, let's go to the another example. Okay, can you see it?
Yes.
I have the example here in a contextual problem especially. Remember the first step, we should make the mathematical model. Okay. To make it easier, because this is contextual problem, we can make the table first. Okay. We have in the question, we have first tablet and the second tablet. So we can write right here, tablets. First tablet and the second tablet. Okay. Okay, the next is the first tablet contains 5 units of vitamin A and 3 units of vitamin D. So we can write here vitamin A and vitamin D. Okay. Don't forget we make let the number of first tablet as X and the number of second tablet as Y. Okay. we have the first tablet contains 5 units of vitamin A, so we write first tablet vitamin A 5 right here, and 3 units of vitamin B. First tablet vitamin B, we use 3, right? So the next is, while the second tablet contains 10 units of vitamin A, we write 10 right here, and 1 unit of vitamin B, so we can write 1 here, okay? In one day, the child needs 20 units of vitamin A and 5 units of vitamin B, so we can write below of this, we can write as the child needs 20 units of vitamin A, we write here 20, and 5 units of vitamin B. We can write 5 right here. The next is, if the first tablet costs 400 rupiah per seat, we can write here cost or expenditure. Right here. The cost is 400 rupiah per seat for first tablet, and the second tablet we have 600 rupiah per seat. This is in rupiah. Determine the minimum expenditure for purchasing tablets per day. So the answer for minimum expenditure we can write is as Z right here. Okay, after we make the table, we can make the mathematical model easily. Okay, so we have 5 right here and x here, so we can write 5x plus 10y. Okay, more than or equal to or less than or equal to?
More than.
Yes, more than, because in the question we got that the child needs. It can be less than that, so we have more than or equal to 20. The second is 3x plus y, right? More than or equal to 5, same. Don't forget, because this is the complex problem, usually there are non-negative, so we can write x more than or equal to 0 and y more than or equal to 0, like this. This is all the constraint, and now we want to state the objective function. We have 400x, sorry, we z first, z equals to 400x plus 600y. So this is the objective function. So the first step is all complete. We go to the next step, that is make the graph for all the constraints. To draw a graph, I will take my ruler. Okay, before that, for the first here, we can divide it by 5. Okay, 5 divided by 5 equals to 1. So x plus 10 divided by 5 equals to 2. So 2y more than or equal to 20 divided by 5? 4. Okay, good. Okay, so we go to the intersection point. For the first x plus 2y, we use equal to find the intersection point. Okay, here we can use, if x is 0, y is equal to 4. Okay, 2. Good. Okay, if y is equal to 0, x is equal to 4. Okay, so we can write 4. So we have 0, 2 and 4, 0. Okay, for the second, 3x plus y equals to 5. If x is 0, y is equal to 5. Good. And y is 0, x is equal to
5/3.
yes. So we got 0, 5 and 5/3, 0. We have found all the intersection points, so we can make the graph. Is it clear?
Yes.
Okay, so we can make the x plus 2y equals to 4. We have 0, 2, so 0, 2. We make a point here. 4, 0. 4, 0 here. we have 2 points, we make a line of it. We can write x plus 2y more than or equal to 4. Okay, for it is upper or down for more than or equal to.
I think up.
We can shade otherwise, so we shade the down part. Okay, so for the second, 3x plus y equals to 5. We have 0, 5 and 5 over 3, 0. 5 over 3 is equal to 1,6669. So we can write, I think here, 5 over 3. We have 2 points. We make a line again. And we can write 3x plus y more than or equal to 5. So, is it to the right or to the left? It's more than.
Right.
Right, okay, so we can shade it the otherwise. Good. Don't forget we have x more than or equal to 0. Because x is more than or equal to 0, it is right part, right? So we shade it otherwise. And same, y more than or equal to 0, we shade it the otherwise. Because y more than or equal to 0, the solution is in the side. So we have the remaining region that we didn't have the shaded area. So we can say that this is the solution region. Okay, the second step is done. Okay, we go to the third step, that is find the corner points of the solution region. Okay, in your opinion, how many corner points here?
I think 3.
Okay, where? We have here.
Yes.
We can let this point is A, and we have intersection here. We can let it B, and here can let it C. Okay, we can write it here. Okay, in your opinion, A is in 4, 0. For B, we didn't find it yet, right? So we will find it later. And we have C. It is 0, 5. Okay, we have 3 points here. So we need to find B. We use elimination and substitution. We have x plus 2y equals to 4 and 3x plus y equals to 5, right? We do elimination for this. Okay, better you will times what?
3.
Times 3, okay. Times 1.
1.
Okay. X, 1 times 3, 3. We can write at 3x plus 3 times 2, 6. 6y equals to 4 times 3, 12. Okay, good. It is same because it is multiplied by 1. 3x plus y equals to 5. Minus or plus?
Minus.
Minus, because 3x minus 3x, 0. 6y minus y, 5y equals to 12 minus 5, 7. So we get that y is equal to 7 over 5. Because we found y, so we substitute this to, what do you want? The first or second?
First.
The first. Okay, so it is here. X plus 2y equals to 4. We substitute with x plus 2 times 7 over 5, right?
Yes.
Okay, thank you. So we have x plus 2 times 7, 14. 14 over 5 equals to 4. We change to the right side. We have x equals to 4 minus 14 over 5. We get that this 20 over 5, right?
Yes.
20 over 5 equals to 20 minus 14.
6.
6 over 5. So we get that B, point B is 6 over 5, 7 over 5. So after this, we found all the points. So the third step is complete. So the next we should substitute all the corner points into the objective function. Okay, we z equals to 400x plus 600y. Okay, let's go together. 400 times 4, 1600, right? 600 times 0, 0. 1600. We have here 400 times 6 over 5. We have that 480. Thank you. We have 600 times 7 over 5. We have 840, right? Thank you. So we 480 plus 840, we have 1320. Okay, thank you. And the last we have point C. 400 times 0, 0. 600 times 5, 3000, right? Okay, 3000. Okay, so we have found all the value right here. So in the question, determine the minimum expenditure for purchasing tablets per day. So we should find the minimum value. What is the minimum value here?
107.
Okay, 1320. Okay, thank you. So we should make a conclusion. The minimum expenditure is IDR or rupiah 1320. So I have another example, another conceptual problem. Remember the first step, we should make a mathematical model. Okay, so we have type A give and type B give. So we can write give here, type A give and type B give. So we let X be the number of type A give and let Y be the type B give. Okay, we have to wrap a type A give, 2 sheets of wrapping paper and 2 meters of ribbon are needed. So we write wrapping paper and we have ribbon. Right? The ribbon is in meter and this is pieces. Okay? 2 sheets of wrapping paper and 2 meters of ribbon. So we write it 2 and this is 2. The next for type B give needs 2 pieces of wrapping paper and 1 meters of ribbon. So this is 2 and 1. Okay, thank you. 50 sheets of wrapping paper and 40 meters ribbon are available. So we can write 50 here and 40 meters ribbon, we can write it here. Okay, the next is the weights for wrapping its type A give and for wrapping its type B give are 5000. We write its weight rupiah 5000 and the type B give is 4000. The question, the maximum weight that employee can receive is, we let it as Z, so we should find the maximum Z. Okay, if we already make the table, we can make the mathematical model. 2x, so we can write 2x plus 2y. More than or equal or less than or equal? Less than or equal. 50, and the second is 2x plus y less than or equal to 40. Thank you. And don't forget we have constraint x more than or equal to 0 and y more than or equal to 0. So all the constraints. And the next is the objective function. Z equals to 5000x plus 4000y. Okay, step 1 is done. The next we make a graph. Okay, don't forget is to make it easier, we can divide it by 2, right? 2 divided by 1, 1. X. 2y divided by 2 is y. Less than or equal to 25. Okay, we can find the intersection point first. X plus 1 equals to 25. If x is 0, y is 25. Y is 0, x is 25. Okay, 0, 25. 25, 0. For the next, 2x plus y equals to 40. If x is 0, y is 40. If y is 0, 20. Okay. So we found all the points here. The next is we must make a graph. Okay, so we already have this. So we can put all the points here. First we have 0, 25. So we can make 0 and 25 is in the middle of 20 and 30. So we can write here and 25, 0 same in the middle of 20 and 30 we have here. So we have 2 points, we make a line. Okay, for the next we write x plus y less than or equal to 25 first, and we have 0, 40 here, 40 and 20, 0 here. We have 2 points, we make a line. Okay, we write it as 2x plus y less than or equal to 40. Okay, we have both lines, and for x plus y less than or 25, is it to down or upper?
Down.
Down, so we shaded otherwise. Okay, and the next is for 2x plus y less than or equal to 40, to the
Down.
okay, down. Okay, don't forget to have x more than or equal to 0. X more than or equal to 0, so we shaded otherwise. And y more than or equal to 0, so we shaded the otherwise. Okay, we have the remaining shaded area. Here is the solution right here. So it is complete for the second step. For the third step, we should find the corner points of the solution right here. Anyone can help me? Okay, Shiloh? Okay. Please help me to do the rest. First, you should find all the corner points here. We haven't found the point B, so we should use the elimination and substitution. Okay, so Shiloh found that x is 15 and y is equal to 10. Okay, the next is you find the maximum value. Okay, you found all the values here. So with the question, the maximum weight. So where is the maximum value?
The maximum is here.
Okay.
Point B.
Okay, thank you, Shiloh.
Thank you, sir.
Let's see the Shiloh's work. Shiloh found that the maximum value is 115,000. Obtained at point B, 15 and 10. So we can make the conclusion. The maximum weight that the employee can receive is 150,000 rupiah when wrapping 15 type A gift and 10 type B gift. Sorry, I used S here. Okay, so for the example here is done. Okay, student, is it clear with the explanation and the examples?
Yes.
Do anyone have a question?
No.
Oh no, okay. If there are no questions, please open your mathematics textbook. Go. At page 25. Okay, already?
Yes, sir.
Yes. There are exercises. Please do number 1 until number 5. as your homework. Please submit it to me next week before your first class in the morning, okay? Okay, students, I think the time is over. Next week we will discuss about the second method to find the optimum value, that is using the rule method, okay? Before we end this class, let's pray together. Pray begin. Okay, pray finish. I think that's enough from me. Thank you very much. I end this lesson. See you next week and good afternoon.
Good afternoon.
Okay, class please erase this whiteboard, okay?
Okay.
Okay.